Welcome back to new exercise in SolidWorks. Here we will create a planetary gear assembly. We will create each and every gear with the help of SolidWorks assembly toolbox. We will edit it and we will assemble at the end, and we will create three types of case for this. So this is the case 1. This is a new exercise in SolidWorks. This is a planetary gear assembly. Here we will create each and every gear one by one and assemble at the end. We have here spur and ring gear table, and here we have a component table also. If you see the note, all dimensions in millimeter. Gear we are going to took from toolbox. Okay, and there are 4 number of parts. Bearing also there, but this is going to take from system ISO standard bearing. Okay, then this is kind of planetary gear we will assemble. Okay, let's do the first part. Now look, this is the first part, carrier. You will see the outer radius 7.5, inner diameter 9. The distance between these two 18, and see 120 degree means there is 3 number of instances. Corner radius 20, and how much this depth? 3.5. Okay, then there is a one shaft at center. The length is 50 millimeter and the diameter is 5. Let's check. Front plane sketch. Now activate circle, and let me draw here 2 circle. Now for the first circle, radius 7.5 into 2. Okay, the inner hole, the hole diameter is 9. Right click, exit. Now select smart dimension. Now let's make vertical distance. This is going to be 18 millimeter. Now look, drawing is still not defined because there is a one constraint balance. Press and hold shift key, select origin point and center of circle and make constraint vertical. See, this is fully defined sketch. Now here I am going to activate circular pattern. First, entities to pattern. So I am going to select these 3. Now point, center point already selected. Angle 360 degree, equal spacing, and 4 numbers. No, there is a 3 number of instances. Say yes. Now just little move and you will see here, select, hold shift key, select these 2 points, merge. Now this is fully defined sketch. Now activate 3-point arc, and let me connect from this arc circle to this circle. Right click, exit. Let me define radius. This radius 20 millimeter. Fine. Now make important relation. Press and hold shift key and select circle and arc. Make relation tangent. Similarly this end, circle, arc. If you leave shift key, you will see this pop up, or even left side also you will see all the details. So tangent. Look, it seems fully defined. Activate circular sketch pattern. Now here in parameters, better to choose entities to pattern. So I am going to select this arc. Now by default system took this center. Now everything is same, angle 360 degree because this is a circular, equal spacing, and instances, make it 3 number of instances. Rest keep as it is. Say okay. Now look, drawing is not fully defined, so just move any one. See, you will see the origin point here, 2 origin point. So press and hold shift key and select both the origin point and merge it. Okay, let me again select these 2 points, coincide. Okay, look, this is fully defined sketch. Now it's time to extrude. Now leave hole and select this body. Keep end condition blind because see, this is moving in perfect direction. Let's say 3.5. Because our bearing thickness is 3.5, that's why we are going to keep this one 3.5. Say okay. Corner radius 0.5, then 10 millimeter from here. You will see there is a 1.8 diameter and 1.5 the thickness. Corner radius also shown 0.5, and then there is one oblong hole, R 0.75 depth. This cutout 1.5. Okay, chamfer 0.5, 45 degree. Then this corner also have 0.5. Sketch Now let me activate circle and start from origin point. Start from origin point and make this circle 5 millimeter. Enter. Activate extruded boss base feature. Keep end condition blind and make the length 50 millimeter. Say OK. Now select this face, sketch. Now there is one big circle and the big circle diameter shows 8 millimeter. Okay. Extrude. Now here I am going to make this thickness 1.5 first. Okay. I am going to change offset. Let's say 10 millimeter. Reverse. Reverse. Now see, this is moving this side and 10 millimeter from here to this end. See how we manage. Okay, let me check. Press this face, and you will see at bottom normal distance 10 millimeter. That's it. Now let's check. Okay. Now let me choose here right plane, sketch, and I'm going to make here one oblong. So I'm going to choose here a straight slot. Okay, better to choose center point straight slot. Right click, exit, smart dimension. Now the overall length of this 5 millimeter and distance from one end also 5 millimeter. And the depth is 1.5. This is fully defined sketch. Now choose extruded cut. But here is the catch. Now let me make offset. Offset, make 5 millimeter, 6 millimeter, 10 millimeter, whatever. Look, this is going to start from this face. Okay. Depth 0.5. Right? No, depth is 1.5 it seems. No, actually the depth is 0.5. Okay, here I am going to choose offset from surface. I am going to choose this surface. Now you will see there is a gap. This gap is 0.5, but I want to cut inside. So here choose option reverse offset. Look, this move inside. 5 millimeter, this is the face of 5 millimeter. We selected offset surface, so this is the outer surface. 5 millimeter depth inside due to reverse offset. Say OK. Look. Chamfer. Now the first chamfer is 0.5. Choose angle distance and select this face. Okay. Fillet. Now we have here two types of fillet. 0.2 constant type, and I am going to choose this face. Okay, again I am going to choose fillet, and this time I am going to choose 0.5 constant type fillet and simply choose this face. Okay. Material, let's define edit material, steel AISI 1020, apply, close. Green color is going to apply according to. Now if you want to change the color for this depth, so simply keep this. Okay. Now let's save this one. Okay, go to desktop, create folder. Planetary gear. Okay, make this one part 1, carrier. Now the next part is sun gear. You will see. Now let me check spur and ring gear. Now here these are the parameters. Sun gear, module 1, number of teeth 12, angle 20 degree, face width 10. Then this is there is a small hub, so we are going to keep style B. Pitch circle diameter 12. 14 is the addendum circle diameter, and addendum circle diameter also given. Now you will see here all the teeth dimensions. Depth here, overall length 10 plus 30, okay, and 5 millimeter is the hub diameter. Let's make this one. Open, new, go to assembly, open. Now let's cancel this all, and I'm going to, now let me activate here origin point. Fine. Now go to design library. Now activate here toolbox, and we are going to use ISO standard transmission power gear. Now first is our spur gear, so drag. Okay, later we will arrange with this. Okay, first module is 1, gear 2, pressure angle same, width 10, and here see we chosen hub style B. Now hub diameter, this diameter 5 millimeter, and the overall length, now overall length is going to be 30 plus 10, 40. See, okay, nominal diameter we can't keep minimum 0.8, later we will make it 0. Okay, we are not going to make any key, say okay. Now cancel, and this is, now I am going to mate, right click, float. Now I am going to mate coincide with plane, otherwise it's difficult while editing, part editing. Now choose here origin and origin of part. See, both are selected, choose here mat. Coincident activated here, say okay, cancel. Now let's me hide. Now let's save as, don't save as assembly. I am going to save this one as a part. So here choose save as a part, and this is going to be part 2 sun gear. See here. Now this one cancel it, don't save. Now open the part sun gear. If you want all the features, whatever you did, you want to perform, go for a feature recognition, yes, otherwise no, because there is already still things are balanced. Okay, now select this face, sketch. Now activate this circle, convert entity, activate extruded boss base feature. Now here I am going to choose up to surface. Now select this surface, say okay. Now hole is filled. Okay, let's see what else. Now there is also a keyhole, 0.75 is the radius, center distance 5, 5 from here, 10 from here, everything is same. 1.5, this diameter also 8, corner chamfer 0.5, something like this. Then there is a one hole, you will see here in this drawing, 7.5 depth 1, 3 millimeter. Okay, so let's go for this. There is a select this face, sketch. Let me make here 2 hole. One is 7.5, 7.5, enter. The other one is 3. Right click, exit. Now activate here extrude cut and make this depth. Here choose blind, and depth is given here 1. Okay, no, there is not full gap. We forget to we need to choose only this face, not this one. Okay, Okay, again let me edit, clear this one, only this face choose here in selected contour. That's it. Now this corner have chamfer 0.5 45 degree. Okay, chamfer we will add later. Select this face, sketch, activate circle, make diameter 8, enter. Extruded boss base, here choose blind, and depth or thickness 1.5. First make reverse, start offset, make 10 millimeter. This is going this side, so make reverse. Look, from here to here. Let's check this distance. Select this face, hold shift key, this face, and you will see normal distance 10 millimeter. This is what we like to keep. Now let's check. See, the plane is exactly at center. That's why we make coincident relation while assembly. Sketch. Here I am going to choose center point straight slot. Make sure apply at center. Right click, choose select and out. Now first radius 0.75, 5 millimeter is the width, and center distance from outer edge also 5, and this cutout depth also 5. So we will do the same method what we did, extrude cut. I am going to choose here offset 5 millimeter. Oh, okay, let's check again. Now this is the face. Now up, offset from surface. Now cut out from this surface. Now look, the gap between these two surfaces 1.5. Make it 0.5. See, the gap is reduced. But I want to cut. This is this direction. So make reverse offset. See, this is going to cut inside. Look, this is how. Let me choose chamfer. Angle distance, here choose 0.5. I am going to select this face. Okay. Again going to choose chamfer. Again angle distance, and this time distance 0.245 into 45 degree, and let me choose this inner one, this inner faces. Okay. Now for appearance I am going to choose polish to all. Okay. Now let me select all. See, that's it. Now let me save this one. This is already saved, just save it, sun gear. Let's make third part, ring gear. See, this is ring gear, and you will see all the specification. Module 1 teeth 60, angle same 20, face width 10 millimeter. Then hub style A, because there is no hub. Pitch circle, addendum, dedendum, diameter, all are here. You will see also here. Now there is the OD outer diameter here, 65. So first we will create this in assembly, then later save as a part, then we will do the other modification. There is one more gear, you will see here, one more teeth here, depth 8 millimeter, and you will see. Okay, let's first make outer one. File, new, select assembly. Now cancel all. Now make it okay. Now here I am going to choose same ISO standard internal spur gear. Drag, Now let's do it. Module 1, number of teeth 60, angle face same. Now outer diameter 65 is given. Okay, everything keep as it is, say okay and cancel. That's it. Now right click, float. Here choose rotate, and I'm going to keep something like this. Okay, now let's select the origin of assembly, control key, and origin of part. Here choose met. Now look, coincide met, going to create. Say okay, cancel. Now later we will manage. Now let me do one thing, save as. Now this one save as a part. This is part number 3. Oh, we already check our folder. Planetary gear. Let me keep bigger. Ring gear. Save. Now this one cancel it. Don't save. Go to open. This is our part 3. You want to feature recognition, say no. You can do yes, all the features will come here, but it takes little time, and okay, I don't need those things. Plain white. Okay. Now look, there is a one more gear. We have to make this one. This is the gear, what we call the profile details. We have to apply while putting profile details. T1 is the initial and ending point of this profile or spline. These are the equations. Just remember this. 8 number of here. Now let me check first. Either we need to change this position. It should be like this. Now look, the gear is going to be at this position. First we have to check these teeth at this position. If this is not at this position, we have to change this one 3 degree. Now let me select this face, sketch. Now I am going to activate line. Now draw one horizontal line and see the line is going to meet here. Supposed to be line going to meet here. Let me check the angle. 3 degree. Okay, we need to change this. Exit. Now just go to direct editing. You can search it in command and find move copy. Now I want to rotate this thread. So let me select this thread and here choose rotate. And here which axis? See, I want to rotate along x axis. See, you will see here x axis. Look. Now here x axis. How much? 3 degree. See, this is rotated. Now you will see at preview. Now look how we change the position. These teeth should be at here. Then we can create, say okay. Now see, before our line is between this. Now that's perfect. Now select this face, sketch. Now here I am going to choose equation driven curve, parametric. Now let's write down all the equations. What we write, 29.5 into Now that there is a close cos t plus t multiply sin t double close. Similarly, 29.5 into parenthesis sin t minus t multiplied by cos t. That's fine. We already written here. Now this is the see, enter start range for equation. So the start point is given here 0.35 and end 0.5. Now you will see the gear this created. Say okay. Now select this one and fixed it. Mirror entity. Okay, let me draw one mirror center line. Select this line, convert entity, make it construction. Now select line, make sure selected copy mirror about this line. Say okay. Now let me select fixed. I am going to choose circle and let me close this. Draw one more circle from origin point or center point, you can say. Okay. Trim entity. Power trim, just left mouse press and hold and drag. Now we have a teeth profile. We need 60 number of teeth. So first let cut. Extruded cut. Choose blind. Let's see where it is going. Now the length of this cutout 8 millimeter, but we have to choose offset. Make it 1 millimeter. Now you will see here, this is going 1 millimeter outside, just reverse. So 1 millimeter here, 1 millimeter here, plus 8 millimeter, total 10 millimeter. Say okay. Now here we created. Now at corner there is a profile 0.25 radius, constant type, and these two corner have same radius. Okay. Now let's make multiple number of patterns. So choose circular pattern. Feature, fillet already selected, select this cutout. Equal spacing, 60 number of instances, and we have to choose one for direction, one circular edge, or let me activate here temporary axis and select the center one. See? Okay. Let's hide. Now let me hide this plane sketch also. Material, let's edit material. Apply close. For appearance, now let me choose feature. Okay. Now that's it. Save it. Let's make the last part planet gear. Now let's check first planet gear. Module 1 number of teeth 24, 10 width. There is a hub. So B option I am going to choose. Pitch circle, addendum circle diameter, dedendum all are here. This is by default, we will going to take from toolbox. Now overall length of this 25, 5, 30 plus and 40 millimeter, 10 millimeter is the width. Then there is a cutout at both the end, 1.5, and this cutout width 17.5, 8, sorry, 18.75, 7.5. Okay, and there is a chamfer at corner 0.25 into 45. Let's do this. File, new, open assembly, cancel it, go to toolbox, again same. If you go to toolbox, choose here ISO standard, power transmission, gear, and spur gear. Now this time spline 1 number of teeth going to change 24, face width same. Now hub style B, because I want this, hub diameter 5, and this one I am going to keep length, overall length is 50, no, that's 40, 30 plus 10. Now rest everything same. Okay, check. Now let's save as this one. Okay, before going to save, let's make a particular plane, so that, because see, this is not lies at particular plane. So first right click, float. Now choose origin of assembly and origin of part, make coincide. That's it. Okay, cancel. Now let me save this one. Part, planet gear. Now cancel it, don't save. File, open planet gear. No, I don't need feature recognition. Okay, let's check options, and let me change image quality higher. Select this face, sketch. Now select this circle, and convert entity, extruded boss base. Make it reverse or choose here up to surface. Select this surface, say OK, and see the hole is done. Let's make hole at both sides. .75, and the inner hole is going to be 7.5. Enter. Right click, exit, extrude cut. Now select depth here 1.5. Keep end condition blind, and see the arrow, it's moving inside. That's it. Now I'm going to use the same sketch, extruded cut. Here start, choose plane, and select this plane. Now you will see this is going to cut reverse direction, so simply choose reverse this one. Same, I want make depth 1.5. Say OK. See, now here let's put chamfer, and the chamfer is 0.25. 0.25 into 45 angle distance. So I'm going to choose this edge, this face, actually not edge. I'm going to choose face, so we don't need to select 2 times. Okay. Now, okay, let's cut this diameter 4.14. There is a thread M 3.5 into 6. So we will make first thread, then we will add this one 7.5. First we will cut 3.5 into 7.5. Then there is a chamfer 0.145. Select this face, sketch 3.5. Enter. Now choose extruded cut and make depth 7.5, and here choose flip side to cut. Okay, see, now let's apply thread. Okay, let me choose this inner edge, start from inner edge up to selection. Let's say here choose up to this selection. You will see the preview. Let's make offset from this end, let's say 2.5. Okay, metric tap the 3.5 into 6, this is the R thread, and here choose extrude thread, right hand, say OK. Now it's time to cut all, so select this face, sketch. Again let me draw one here, 3.5, enter. Now choose extruded cut, reverse, flip side to cut, say OK. See, now I am going to select inside one, 4.14, enter. Extruded boss base, and this is going to be extrude 2.95 according to, say OK. See, chamfer 0.145 degree. Okay, let's leave this edge so it looks more clean. Okay, let's this one keep as it is. Material, edit material, apply close. Feature, let me select this also. Now see, okay, save it. Let's make first sub assembly, this carrier with bearing. There is a bearing ISO 7040, 3 number of bearings, new assembly. Now folder is open here, open. Now let's open this origin. Now move cursor, it's fixed on origin. Let's hide origin. Now go to toolbox, ISO standard. Now bearing, ball bearing. Now angular bearing, just drag and keep this face and this. Okay, let's keep this one. That's it. Now bearing size I am going to choose 284 because the bore is going to be like 9. Detailed, apply cage, so it looks more realistic, no? See, it looks more realistic. Say okay. Now again another bearing, so just keep on edge and fixed here. Just keep a cursor over the internal face and fix. Right click, cancel, matte. Now select this face and this face. Make relation coincident. See, the bearing is perfectly flush with this. Fine. Let's check this face with this. Coincident relation. Okay. Now this one save as sub assembly. Sub assembly carrier. Now cancel this. Now let's start new assembly. Okay, first part, what I am going to bring, I am going to bring ring. Open. Now let's open this. This is important. Okay, I want to change this position. Now look, this is this direction. So what direction? Let's say y axis. Rotate. Oh, that's perfect. So I just click move on and see this is fixed. Plane. Now let's uncheck. That's it. Insert component. Now select this one, control key this one. Now this is also position I want to change. So which, let's try Y. 1 time, 2 time, 3 time. The shaft should be backside. Place somewhere here. Now the second one, this shaft we will make in R size. Okay, this is look like this. Okay, let's fix first this one. Mat, standard mat, and I am going to choose this circular face and this circular face. The first relation coincident. Okay. Now select this face and this face. Okay. Now this is perfectly fit at center. See, this is rotating at center. Similarly, let me choose this face and this face. Coincident relation. Okay. Just rotate somewhere here. Let's make multiple number of patterns. Either you can browse the part or simply press Control key, click with left mouse and drag your mouse. See, we created part. Again, click, drag. That's it. Let's select this face and this face. Coincident relation. Somewhere here, select this face. Okay. Let's bring our plate. Plate we will fix, then we will see how it's going to work. Sub-assembly. Open. Rebuild and save. Okay. Go to mat. Select this one and this one. Coincide. This one. Just drag somewhere here. And inner one. Concentric relation. Okay, not coincide, it's concentric relation. Similarly, select this face and this face. Concentric relation. Okay. Now let's make fix. Select this bearing face and this wall face. Okay. Cancel. Now let me check this quality of this assembly. Make it higher so that we will get okay. Now see. Okay, let's make one more important relation. Select this shaft and this outer, inner and outer shaft, concentric relation. Okay, cancel. Now let's try to rotate. See, now the most important mechanical mates are balance. Let me first save this assembly. Save, rebuild and save. This is going to be Planetary gear assembly. Save. Now it's time to add mechanical gear or mechanical mats. So just go backside. Before going to backside, we will do one thing. Let's fix this one. This is rotating. Now right plane of this and select the right plane. Press Control key, right plane of assembly. Now here two plane we selected. Now you will see there is a gap between these two planes. So simply here choose mat, coincident mat, and here select use for positioning because I want to use for positioning purpose. Okay, cancel. Now right click on sub assembly, fixed. Sub assembly is not able to move now. See. Now select this face, normal view. Now let's arrange this teeth. Now see, teeth is perfectly aligned with this. Here also perfectly aligned. Here also perfectly aligned. Now only thing is, okay, that's it. Try to keep at center. That's it. Now let's activate mat. Go to mechanical and activate gear mat. Okay. Now first these three planet gear we will mate with outer ring. Okay. Then any one gear mate with sun gear. So first I'm going to choose this one. So I'm going to select this internal or addendum circle diameter. This is the addendum circle diameter, and for this addendum circle diameter. Okay. Now here ratio, how much teeth? 24, and this is going to be 60. Uncheck reverse, say okay. Similarly going for this, activate gear mat, this face and this face. Similar thing, 24, 60. See here, you will see the teeth and both teeth diameter. Okay. Okay, these two done. Let's check this. Activate gear, select this face and internal face. Similarly, 24, 60. Say okay. Okay, the last one, gear, last one with whom, let's mate with this. So I'm going to choose this sun gear addendum circle diameter and this one, how much? 12 number of teeth. This is 24 number of teeth. Okay, but make sure you selected reverse because in this case this gear is going to be rotate reverse. Say okay, cancel. That's it. Okay, we have to right click, float. First let's make it okay. Now let's rotate and we will see. Okay, see the gear is rotating reverse direction. So I am going to edit those all mats. First one, edit, choose reverse. Okay. Second one, right click, edit feature, reverse. Okay. I think third one, edit feature, reverse. Okay. Cancel. Now let's rotate. See how this perfectly rotating. Use this one. See, even let's close loop. See, the sun gear also perfectly met and rotate at any direction. Similarly, let's check at this. See, see, that's it. Now we are ready. Let's save it, rebuild and save. Now we will do other study also. Let's make some, we will fix something or some moment we will change. There is a 3 cases we will go for this. Now look, right click, add configuration and write case 2. Okay. Now in case 2 I am going to fix sun gear. Right click, fix this component. Okay, then ring gear I am going to free. Right click on ring gear, float this component. Now let's move. See, now sun gear is fixed in this case. See, see, sun gear is fixed, only these are outside rotating. Now let's create one more config, case 3. Now in this case sun gear make float. Right click, float, and carrier we are going to fix. Go to assembly, right click on sub, fixed this one. Okay, now this is fixed. Now let's see what is going to move. Okay, look, the ring also going to move and all gears are going to move along this, but the carrier is going to fixed. Take it normal view. Now let's move carrier. Okay, look, see, sun gear, planet gear and ring, all gears are moving, only the carrier is fixed. Let's go to here, double click and activate default. In default everything is rotating except case. Let me save this one, rebuild and save. Right click, motion manager, go to motion study, and first I am going to change motion frame 50. Motor I am going to apply to this shaft and let's say small 10 rpm. Okay, and here choose calculate, and let's say what is our output. Drop down, play. See, sun gear is rotating fast but planets are moving slow. You can even go back, play. If you want to save this one, let me click save, write part name .mp4 file screen, and here ratio I am going to change. See this ratio here 16:9. You will see like this picture. Frame 50 frame is enough, it's giving save. Now this is calculating. Once this calculation finish, it will save in your destination. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Please share this drawing. If you want to download this JPG file, just go to my Facebook page. You will get all the details drawing there. File size is too big, so you don't need PDF file. Thanks for watching. We forget to add nut here. Just go to model, toolbox, ISO standard, and let me chase where is nut. Okay, hexagon nut prevailing torque 704. This is going to be fixed. Just move cursor over on this, and this is fixed. Just first move. Okay, this is going to be M3. Schematic. Say okay. Now first move any curve edge. Okay. Now this is fixed. Save it. Now again go to assembly. Calculate. And play. That's it.